Building AI-native enterprises, a practical framework for CTOs to leverage ethical AI system in production, and a keynote talk for AI in the New Era 2026. Let's get started. Did you know that over 85% of teams are past the planning phase in AI agents, and yet only 14.4% have full security approval? Even more staggering, 88% of organizations confirmed suspecting a security incident this year. Let that sink in. Imagine this applied to any other field. That's how high it is with AI agents. And even worse, if we ask from a gravity study how many of our agents are actively monitored, we can see that 1% nearly have no monitoring, and only a very small percentage actually monitor all their agents and know what they're doing. Imagine this applied to another part of your organization, where a huge part of it, you don't know what's happening, why, and the risk associated with running them. AI usage among employee parts of the organization is very scattered, and this creates loads of risk. And if you feel the pressure of agentic, AI first, AI powered, AI everything, AI washed, maybe, this talk is for you. I am Lorenzo Satta Chiris, an AI research and system engineer. I've worked on multi-agent system, agent autonomy, agent AI, AGI alignment, and I've also worked on the Aura framework, which is a system to make AI safer. And today, we're talking about CTOs and company and developers, how we can make AI and agents safer in our organization through auditability, control, and most importantly, improving the ROI and long-term potential of agents while minimizing the potential legal and governance risks. In the future, we're going to see a new organization, which is mixed environments of humans and agents. Some more, some a bit less, but there's always going to be those shadows agents like assistant that'll do research in aspects for us. But even more than that, we'll see teams of sub-agents that act on our behalf and work with us. And you can see here, as small maps, you'll have the CTO, you have silos and groups, they all collaborate, maybe they have a central governance information system in the middle and more. But there's humans, there's agents, and hybrid system. And you may see something missing here. Where's the CTO? Well, the CTO, he sits here in the cockpit. And he sees here the agents, the data layer, the governance. He also sees here the operations, the risk, the people. He's not necessarily flying the planes. It will be impossible to control all the agents. But he's the one setting the course. He's the one monitoring the system. And he is responsible for ensuring that the agents and the system have and keep the company edge. And as such, we're seeing a transition from instrument to actor. We had the command line interface, the graphical interface, and now an agent intent-based interface. And this is very important because the way we interact with knowledge, with data, and produce value is changing very fast and in a lot of ways. Because right now, with an agent-based interface and an agent-based system, I'm no longer working on the actions per se, but I'm working based on intent. This is what I want to do. I want to book a flight per hotel for a conference. I want to get this report done for this company. And then the agent will figure out the steps. But if I don't know those steps, if they're wrong, then it may mean that my final output will be worse or plenty of errors or even more riskier, having actual governance and legal risk. And as CTOs in a company, it is the role of the CTO to manage software aspect, the technical leverage and technical aspect of a company, but it will become a shift to become even more and more managing the agents within the company, managing the way agents can be used as leverage for the company IP, making sure that it does not go public through AI problems, but also very importantly, making sure that those agents are effective, deliver proper ROI, are technically capable, and also safe and secure. And thus, we can see that we are in the cockpit of this change, navigating and directing the agent company. What is agency? Agency is the structural capacity of a system to perceive, interpret, decide, remember, and act. So what it means is we have the capacity to make decisions. And when you see an agent, it's an autonomous piece of software that can make decisions within an environment and a system to do actions on our behalf for us. And most of the time, it's consequential effect. So maybe sometimes you can reverse it, but most of the time you can't. And even if you can, it still has an impact in that environment across time, systems, and more. It usually works with people and perceives the environment in various ways. It makes a reasoning and then makes decisions. This is where an agent is different from a workflow, whereas when we work with traditional software, it's input in, output out. We can kind of unit test it quite, not easily, but simpler. With an agent, we have that complexity of non-determinism, of randomness in a certain sense. And so we need to work more from for instance, testing in terms of more user experience from a human experience point of view of what is the relationship of the software. Or if we actually use agents within an organization, we have to ask what they can touch, how they can touch that, how they act within the system, what they are changing, what they are working on, what knowledge they draw from, and plenty more questions that we're going to see in this talk. So if we want to break that down a bit more, we can look at the anatomy of an agent and really breaking down into the main steps. Usually we can divide into 3 pillars, which is what the agent gets in, so the input, the context, the perception, what the agent does, so how it thinks, the model, and then what the agent thinks, the model, and then what the agent does, which means what actually are the actions. So from how it perceives the environment, we have the perception layer, which is things such as chat or voice or images. I mean, if you've worked with Claude or ChatGPT interface, you've seen obviously all of these aspects, but also the prompt or soul documents, the interpretation. How is the agent? What's the tone? What's his style? What's his persona? What are guardrails? The context, so where is it getting its information from? Is it, for instance, through a specific RAG model? Is it getting through a set of files? Where is your information? It's going to be a huge part of this talk. It's very important from a governance point of view to know where the data is coming from and what data we're working with. Obviously, the planning. So how is it reasoning? Is it using an orchestrator? Is it a multi-agent system, meaning multiple agents working together? Or is it a single agent? Is there some aspects that are more of a workflow step by step, or is it actually fully open-ended reasoning? And then you also have, very importantly, the reasoning step, which means what is the foundational model we are using. So is it a GPT? Is it a Claude? Is it another type of model for image generation? Is it multi-language? Is it open source? Where is it hosted? How? And also the actions. So how is it acting, this agent? Is it working with an MCP server? Is it connected to an API? Does it access to a browser? Can it actually run commands on a terminal on a computer, or maybe edit a database, or maybe work with files? Is it read-only, so can it only read, or can it actually make action on a database? If you can edit a database, to what level can you edit? Could you run a command and delete your entire production database, for instance? And then collaboration. How is this agent working with the human? Is it through a chat interface where the human put a question, the agent replies, so like customer chatbot? Is it through actually a card, such as Claude is rolling out right now, or interface kind of generative interface design? Is it through maybe Slack or WhatsApp, or a communication channel such as OpenClaw, where it's directly to the consumer, and the consumer can make decision on the platform he's used to kind of interacting with? And then how does the agent improve and learn over time? Does it have a static memory? Is it actually a memory based on database, maybe a vector embedding memory? Or is it, as we've seen with Claude Code Leak, is it kind of a set of markdown file with several levels and a smart system where sometimes it's a working memory, sometimes it's based on a single project level memory, sometimes the full kind of user profile memory? So we have several layers here. So these are 8 examples of pieces that kind of build the agent and the agents we can see in our organization. And as CTOs, we're going to have to build this agent, or at least govern people to build it for us, and interact with them, and make sure that each one of these steps is properly governed, auditable, controllable, and safe. So one tool that is amazing to do so is the agent card. So imagine you have a CV, or kind of a job role profile originally, and you want to hire someone for a role. Are you going to set up specific aspects, things you're looking for within that CV or within that role? And then when you also apply, you are going to write and create those aspects, or kind of show you off those aspects. When we build an agent, we can use a similar system. First, I write what I want, what I need, and then I try to find the best agent, either building, adapting, or having one that is already made that kind of matches the job role. So if I look at an example of a lead enrichment agent, I'm going to have various fields. I look for an agent card. So what's the task? What is the agent trying to achieve? What are the required capabilities? What tools does it need to use? And we can see here parallel with the 8 points we just looked at what constitutes an agent, obviously. What's the prompt architecture? And this is very important with LLM-based agents, where the prompt can change so much in terms of output. So if it's a smart system prompt, do we want it to be more kind of step-by-step? What examples? Do we go zero-shot, multi-shot prompting? What's the amount of budget we're giving to the reasoning part of the equation? And the blast radius is very important. So what is my agent actually able to interact with and how? This is where we have governance coming in. Autonomy level, we're going to talk about that, is very important. The governance layer as well, and the improvement loop. So looking at a lead enrichment agent, we can see like the task, okay, I want to reach inbound leads with company data before rep outreach. So the capabilities, it needs to be able to look at LinkedIn, maybe email, the internet, or other. Prompt architecture, how I'm going to prompt it. Do I want it to be literally like giving a process and say, do this, do this, do this, or do I want to leave him the decision of and how much decision I want to give him? And then the autonomy aspects and the more kind of governance aspect is what data should I give it access with? If I give access to some data, it may be non-GDPR compliant if I have a lead, for instance, with depending on my jurisdiction and how I'm working with. Given this conference is global, obviously there's be a lot of difference, and we're not gonna cover them all. In terms of autonomy, in this case, probably I'll say go with a level 3, supervised. So the agent has a lot of autonomy, but it still needs to have human approval before doing consequential decisions. Who owns it? Maybe the head of the specific department or the specific person, and how often do we review it and improve it? And finally, say the improvement loop. So what is the way so that we can know how it is going and then make it improve over time? And we can use a very useful tool here, which is the autonomy gradient. Here are 5 levels. It can be divided even more, but the key idea is here is to know, based on my agent, how much autonomy I want to give him. And we're going to measure that based on the risk and various other aspects. But it's important to ground it up. And that's why in this talk, we're going to cover 5 core points. So manual, the human does it. Assisted, the AI recommends, the human does everything, all the decisions. Supervised, there's a switch here. The AI starts executing more and the AI is the one approving. Whereas assisted, I'm doing the work and the AI is giving maybe advice or recommending. In this case, a very important switch. It's actually the AI acting and I am supervising. Delegating, it's even stronger. AI is still executing, but we just delegate. We don't approve all actions. We're actually just saying, you do this. If you need my help, come and call me. And autonomous, even more, AI does everything, I just check. The goal here is to have a balance, to be as autonomous as possible in the action so that we have less work to do, but as manual as possible in the safety and the governance aspect, in the terms that I want to review everything that is very risky, make sure that the performance is good, and then the advantages is dual. Obviously, the first is the governance ethical aspect, and the second advantage is very strong, is the performance aspect. I get higher efficiency, other ROI, and improvements if I am actually giving advice, giving my know-how, making sure it's properly integrated within the system. And this is where the integration within the system acts upon a context layer. And we've seen with AI, there is a very strong advantage in centralizing the information. And we can see here data, information, knowledge, wisdom pyramid, which is important. But as a key learning here, it's kind of 3 things to work with data. Centralization is very powerful. So centralizing not only the data, but also the knowledge and even more wisdom. Because if it's written in the policy, for instance, an internal policy, that this is the specific process, but then in practice, your team does not follow that process, you're going to see the usefulness of the agent will be capped, maybe 30%, 40%, maybe even 20%. Because yes, it can follow the rule by the line. Maybe the rule is not correct because in practice, it's not how things have been done for the past 5 years. Maybe in practice, actually, this is the person responsible for this channel because he's been taking that job. So a lot of things may be certain ways in the data you feed the agent, but actually in the operational reality, they're very different. So if you don't have that loop between actually how things are working and your data, you're not going to get the highest ROI from agent. Centralize is 1. Protect is 2, very important. So the idea that if you give the wrong data, it can go public, especially for public company, but even private company, you want to protect your IP. So making sure your data is given to the right models in the right way. It's not publicly accessible, yes, but also it's not used to train AI. And finally, also versioning, having proper improvement cycles where you have version 1, testing to A/B testing, 2 versions, and seeing how your agents can be as useful as possible. If you have an agent that will, for instance, help and assist in making data review faster for a team, taking an example here, if you have a specific process in place, one is maybe the process of written, one is the process that you do in practice, you want to make sure that you actually have the agent co-developing that process and co-improving the process with the human, where the human can give feedback, the agent can improve its own system, maybe through a human writing it, or even the agent improving itself and changing that itself, maybe through a part which is like a system prompt and client prompt, and then from a user perspective, actually giving tips and giving directions within a certain limit. So there's multiple ways it can be done. One is agent communication. So one is LLM prompting. So having literally just the human prompt the agent itself. One is agent to agent. So having multiple agents discussing and prompting themselves. Model context protocol, which can mean having servers and software connect to a server to the agent, but also reverse delegation, where it's the agent actually connecting and talking with the human or the other agent and the software. So it's very important to have that context layer pyramid and context system to have a way for having an agent to human, agent to agent, and agent to tool, agent MCP communication style. And then we can link that also to an agent economy. So in a certain sense, also a CTO, we need to ask, what are agents? What are they talking with? How are they talking? How they're communicating? And also, how are they buying? How are they interacting with money? What's the budget? How do we communicate the value of agent? How do we measure and track the value of agents? Is very important, because if I cannot measure it, and most of the time it may be not directly monetary, it may be linked to time saved, it may be linked to resource saved, it may be linked to, would have taken 6 months to do that, it takes a month because the agents were automating all of this process. How do we measure that specifically? And then also, how do we make agent pay if the agent is interacting with a specific software? How does the agent pay for that software? Or how are we giving a budget to our team to use agents, and to what extent? And then marketplaces, how do we make the humans, as we say, select and say, I want to use that agent, these specific agents? Are we building agents in-house, or are we buying them from where? So from this section, what you have to remember from the context layer is that it's very important when we build our agent system, as in our enterprise, to look at what's the context they have. So what are they working with? How are they communicating with that context, and based on that context, so to humans, to other agents, to tools, and then how are they paying? How do we have the value? How do we have the monetary layer on top of that? So how do we communicate the value? How do they pay? How do we actually have humans pay for it? And this is where we have the governance step. And if we take all the things we've got so far, that's the agent bit. And now the core, very important word from the title of this talk, ethical, and also working in production. This is the next step. Governance is the layer that allows to move agents from more testing ground to actually going and working fully in production. And here we can see an example of an OPAC interface. So if we can read here, an example where we ask a query, review my control and flag risky clauses. And then the agent thinks again, process, and then we've got an action that is irreversible, done without any approval. So here's an example of an agent that maybe this is even the correct action, this is exactly what I want to do, maybe not, that's not the point. But we've seen plenty of problems here. And if we build even the perfect, most performant agent on the surface, oh yes, it's very fast, and it knows what to do, it has the perfect context, and I'm sure it will do great. You're putting your trust in, I'm sure it will do great, but you're losing all the governance step, which is making sure that one, interface communicates and I know what the agent is doing. And this is said as the dual advantage, which is both the governance, but also the performance advantage. If I can audit, if I can control what the agent is doing, I have the advantage of making sure that it is obviously doing the right thing, in the right way, in the legal way, and interacting with the right system, not making any reversible choices. So let's have a look at a sample, a kind of failure of agents. Getting in the car here, all good, buckled up, ready to go, driving, and wait, there's no steering wheel, no brakes, no control, I'm full speed. And what happens? Oh, multiply that by 40. No coordination, no guardrails, no brakes. This is agents in production. It can be very autonomous, it can be very fast, but if I have no steering wheel, no brakes, no governance, That's the problem. Now we're going to build them in. One of the things we need to focus here is the UAI Act. Even though the kind of a global audience, I believe this is a very good case study because first of all, it's in force and it's gonna come even more in force in the following months with other aspects. And it's a global resonance, even though it's a local act, because it will have a ripple down effect in plenty of other countries. And obviously, if you work in the EU, it's very, very relevant. So why should I care as a CTO or as a company manager? Well, I should care because enforcement is live and will be even more. So the act is in force. It's next 5 months, there's going to be even more part in force, and there's high risk obligations. Autonomous agents are in scope. So if I have system making autonomous decisions in pretty much all the fields and real world consequences, they go into the act. And the penalty is very expensive, so it can go up to 35 million, 7% of global annual turnover for the most serious violations. That's how big it is. So that's why I should care. What does it mean for me? So you need to classify actions, so prohibited, high risk, and limited, minimal. So look at what is, for instance, completely prohibited, social scoring, manipulation, other. What is high risk, so it needs to be properly managed, so full automation, credit scoring, and critical infrastructure. What is maybe a bit less risky is non-legal advice, very important. I'm just giving examples here. And then this means that for most enterprises, we need to very focus on things such as transparency, human oversights, and auditability or decisions. Sound relevant? It's very, very relevant to what we've been just talking. So this means that UAI acts as a takeaway. It's not a blocker, obviously, but it is a governance specification. It means that we need to build with and for it. And that is very important. So one of the best way to do so is to have an audit trace. So an audit trace is a way to know what the agent is doing, how, and what happened. So this means if I check here an example logs from an agent, I need to know what. So what's the specific agent? What are they doing? How are they doing so? Why? So what was the intent? Did they add a specific reasoning? Who? Who's doing it? Who's running it? If it's maybe in production, I need to anonymize it. If it's internal, I can have a system. But then I need to know who and why is using that. And then also the outcome. So what happened? Was there any anomaly? Was there any risk? And I have more examples. So like what? An email draft sent to external vendor contract. Why? There's a follow-up from a trigger. Who? So it's a sales pipeline agent that writes the agent is triggered by this specific person. And the outcome, the email was sent. The email is logged. So if there's a problem, the email was maybe reviewed for safety by a human before sending it. And in this case, there's no need to kind of at a governance level. It's all good. Then here, governance flag raised. So what? Contract negotiation initiated, an external legal document. And the agent deferred approval from private email exchange. So we will approve the contract. So we are in the same kind of pipeline of emails, but the agent cannot reply and say, yes, I'm approving a contract because he's a sales agent and he's working kind of building the sales. The human, it's actually succeeded because he built that sale, but we don't want the agent to go and sign the contract and send an email saying, yes, I approve it, without reviewing the contract, without having a human review the contract. So it's been cut from the audit. I can see what's happening. I can see what the agent is doing, which is much better than an employee just copying paste all the emails, sending that to ChatGPT, where it may be non-private, it may be used to train ChatGPT, it may give something false because it has no context. It may actually even worse, kind of sign something or say there's no worry and lie and hallucinate. So we have to catch that from an audit level, even better control it, so halt the action, then escalate it to the person that's responsible, CTO, or for instance, for such a contract, will probably be someone from the legal or sales department to actually see and approve it. And then we can continue, so kind of, then we can have a improvement system where if we see that, for instance, this thing was really risky, we have to change the autonomy level to kind of, in this case, we say, okay, we go to a lower autonomy level because it should not be able to actually sign contract itself. It should always have a human to review that and more. And then we can link the audit system with a control system. And is what I've been working on at Orbital, and I'm really happy to contact me if you want to have a chat around that. But the idea is, how do I go beyond audit and control what the agents are actually doing? So these are examples of control mechanisms that we can have. Things such as a kill switch to terminate agent execution if something is going bad. Agent, I want to delete all that database. So stop everything. Have a human reviewing that maybe. Action blocking. So say, okay, you block that action. You continue, but you block that action. You cannot do that. You cannot run these commands because the risk is too high, and I cannot have a human now to evaluate it, for instance. Sandbox mode. So say, yes, you're working with a browser. Yes, you're responsible. You could have from injection, but also, yes, you are in a sandbox. If you get prompt injected or if the MCP vulnerability, you can actually control that. Rollback, not always possible, but very important. I can actually click a button and revert those 1,000 code line changes. I can actually click a button and say, okay, the email is maybe sent after 10 minutes. I've got 10 minutes to review it or something like that. So if I want, I can maybe say, don't actually click the send, actually make me do the edits first. Experiment loop, as we said, very important. So actually A/B testing against a control before full deployment or even in deployment and having various tests and making sure that I'm controlling what it's doing and how. And this is the technical answer to the problem, but governance is a lot of the time not only a technical problem and also a human problem. So we have to look into that. Things such as assigning the ownership for the action. So making sure that there is someone that is responsible for that agent, responsible for the action, responsible for the improvement of the agent. Making sure the teams are properly trained. So either running training or having an agent that trains the team or any other way, but making sure that the staff knows how to interact with agents, knows how to risk assess the agents, know what are the main governance requirements based on the specific agents they're interacting with, making sure they use the right context, they don't give data that could put your company in jeopardy, they don't have hallucinated data, they don't lie inadvertently. Another risk is, for instance, copying other people, because agents can come up with things that actually are copied, but you don't know, so you can take that by mistake. And also, finally and third, defining the escalation path. So making sure that you know what the agent is acting and how. And to do that, we have built Aura, which is an agent autonomy risk assessment framework. It is going to be a very important part of the talk. So Aura is a framework I developed with Ayush Mishra to make agents safer in production. And we've built that around 6 to 9 months ago. And we're working with companies and also doing some training for organization on how to apply agents. And we realized that, as we just say, that governance was one of the big missing layers here. And now there's been a lot of more entrants. Microsoft is working on the space as well. But when we built it, there were basically no system at scale that allowed to have that balance between autonomy and oversight in an optimized way. So we built a framework, which is now open source, that allows for organizations to build agents in a safe way and make sure that at scale they are compliant, governable, auditable, and controllable. So it works on a 7-step process, which starts with identifying a multi-agent system, breaking down that into an agent. So I get my agent, and I have 7 steps to make sure that it's governable. 1, decomposition. So I want to break that into actions. This can be complex because you say you don't know what the agent is actually going to do. So you have to either take an existing building in production agent, so you can have a system to measure the actions, so for instance, in code, or you can see what are your functions if you use, for instance, a framework. Or for instance, if you're thinking about building an agent, you can start from the agent card that we defined, and from that agent card, go and identify all the action it needs to do, all the tools it's accessing, all the models it's accessing. Once you have broken that down and you know this is the MCP tools it's going to be using, this is the agent to agent, this is the agent it's going to be talking to, this is the API calls it can do and how, maybe also the parameters, you put that into a context. So this means that you basically, if you do it manually, but most of the time it is meant to be fully automated, you only do the human in the loop, you take that and you parse the actions through an LLM or manually, and you also check the memory for matches. So an advantage is, over time, you want the system to be more and more based on your organization as the context layer. So Aura remembers past interactions and then improves over time to be fit and based on what you want to do. So you got your agent action. Let's take a sample action. Connect with a database. You take the context. So what's basically what the aspect that this action entails. So it's interacting with this database. That's the commands it can run. Then you identify dimensions. So how should I measure this? So this means, such as when I look at risk, is it reversible? Is it, for instance, how efficient it is, could be another dimension. In terms of safety, could be, is it GDPR compatible? So identify dimensions could be from a policy, from a governance framework, from anything that applies to my field that allows me to score the risk. So for a database, for instance, the action of writing is probably reversible, but is still high impact. Reading is obviously fully reversible and lower impact. Deleting, maybe not reversible, and maybe really, really high impact. So you can see here, based on various actions we decomposed, we can have various contexts and thus various dimensions. And that's the step 4, which is scoring. So for each dimension, I go and I score it, and I give it a score. So deleting, that's a score. Risk, that's a score. And then from that, I can build a graph that gives me the risk analysis of my agent. I can compute that and get a full kind of gamma score, risk score from 0 to 100, if I kind of mathematically put that into 0 to 100 form. So then, for each action and for each agent, I can get my score. For instance, here as an example, 0 to 30 is a low score, 30 to 60 is a higher score, and 6 to 100 is very high risk score. And then, based on the score and type of risk, I can select a mitigation. So if it's a very low score, I can auto-approve it. Okay, it's good. If it's a medium score, I will gonna say, okay, I need to have a mitigation, so a human to review it, or maybe another agent to review it, or a system to run. Maybe I do a backup of the database before doing that action, or something like that. So an automated safety. 60 to 100, maybe I block it entirely. That's kind of the red button, stop, go to a human, make the human review that before. And then you connect that to observability and control, which means that every single one of this process gets audited and gets saved, so I can know what happened. I can have a human actually influence that, change the scores, change the risk. And also, I can open the box and see exactly for each action what was the risk, how, and get this 3D graph, knowing what are the points of high risk. So then I can apply my mitigation selectively to lower the risk. If the problem with deleting something from a database is that there is a very, very high, for instance, irreversibility, it's very high score because the risk is very high, it could be that the mitigation is doing a backup before that. Why? Because it attacks specifically the part of high risk. And this explains it very clearly. So imagine Aura is a control tower, and you have an agent that is incoming, so it's requiring clearance. This one is safe, low score, cleared for approach, all good, you can land. Then you get multiple agents. I need to assess all of them in real time. You can go all good. Oh, you, yellow, you need to be redirected. Wait, go in a holding pattern. You need to check that. Oh, you're an undefined agent, you're red, you're very high risk. We're gonna stop that, deflect it, make sure you don't do this action because it's very, very high risk. And then with Aura, we can kind of control all the airspace, make sure that all the threats are neutralized, making sure that every agent is governed and every action is accounted for, making sure there is no accident from start to finish. Having a control tower to make sure our agent works properly. So Aura is open source. You can download it and apply it to your agents, or you can use alternatives. Here, the main goal is to make sure that your agents are governed, accounted for, and that you measure the risk and that you apply the correct mitigation for what is happening. The advantage of a framework like Aura is that the human in the loop is optimized. So if you approve an action and say, okay, I want to always approve it, then it goes and always approves it. And it learns from your behavioral patterns to make sure that in next times and over time, it improves and aligns to you more and more and more into your organization, to your systems. So it knows who to contact, it knows what's the best mitigation for a specific risk, and most importantly, it knows how to properly measure and quantify the risk based on the agents you are running in your organization. So we can look at an example here in production, so real deployment. And then take a multi-agent system. So we're assuming we have kind of 4 agents working from still taking the same example we had in this full talk. So kind of a B2B sales pipeline. So we have a lead data enrichment agent, an outreach email drafting, an external vendor messaging, and a CRM pipeline update. So these are 4 agents, and that's what they do. First of all, we're gonna do the composition, break them down, and identify kind of the top dimensions. So this one, we care about privacy, data integrity, this one, consent fairness, this one, consent autonomy and oversight, and this one, auditability. Then, based on these dimensions and on the actions they do, we measure their risk score and their risk level. We have one that is low, it's just an update, auto-approved. This one is actually higher risk. So I actually want to log, rate, limit, make sure that it cannot get abused. This one I want a human to review before sending an outreach email. This one is very high risk because a message to a high profile clients are actually going to block it and say, I always want a human to review it properly and approve. And it needs to be that specific person that's responsible for that thing. And here we can see that the system, it led some things through, some things it redirected them, and some things it properly blocked. Let's say, okay, you got to do this. So the result and the advantage here is that you got zero unintended external actions post-remediation. And your memory then learns it. So the next time you rerun the same pipeline, your same multi-agent system, you're going to get it optimized and running even faster because it knows exactly who needs to approve it. Just send a message to that person on a specific channel. And we can here see the paper, for instance, is obviously math behind it. So there's a reasoning. This is the process we've just seen, how it works. And most of the time it'll be automated. So it'll be agents doing all the maths and calculating the risk score, making sure it is within the boundaries. And then we can see here, for instance, taken from frameworks that are in act and enforced. What are the core dimensions they present? So we can see here the UA Act we talked about, but also NIST, UNESCO, Recommendation on the Ethics of AI, and many, many more. You can then apply and have the specific mitigations and dimensions you want specifically based on your jurisdiction and on your use case specifically. The advantage of Aura is that it's fully modular. So you apply the mitigations you want, you apply the dimension, you apply the agents you want, and then you get a system where you know the optimal way to measure the risk, audit it, and control what's happening and how it's happening. So I want to leave this talk with an agent decision framework. So a system for CTOs or even developers or companies to adopt agents in the optimal and most efficient way. And I have here 5 kind of core decisions points, which we're going to look at together. So if we look at it, first one, should we use an agent at all? So kind of also build vs buy. So it is very important because for some actions, you may not need an agent. So is a task repetitive or rule definable? Sometimes a workflow may be simpler rather than an agent. It's literally just step 1, step 2, step 3. That's simpler. I don't need kind of any open-endedness. It can be programmatic. There's no need to have agents for everything. But also, is the data available and accessible? Is the cost of a mistake acceptable? And is humans being the bottleneck? If yes, for most of those, then yes, an agent is a very good thing, because if I can accept a mistake, if a mistake is not fully catastrophic, then I can have an agent doing it. If depends also on the type of agents. We've seen that the autonomy level can depend. So there's not just a yes, no, there's a gradient, obviously. But also if the human speed is the bottleneck, an agent can probably help and make it much faster. If the bottleneck, the human takes 5 minutes, the bottleneck is a very complex simulation software, yes, the agent will make the process a bit faster, but it's not going to simplify and transform my organization. If the big bottleneck is obviously large manual actions, that's where agent works best most of the time. If there's absolutely no data and it's a new process, most of the time, I'm still going to have a very higher human involved, maybe not the agent straight away, or maybe have a start where it's very co-development with a lower level of autonomy to make sure I build that proper context and data layer to then build my foundations upon. Once I've determined that, I say, okay, gotta use an agent, can decide, yes, I'm gonna build it, I have the capacity, I need custom, I can use Claude Code or a tool to build it, or no, actually, there's this one, I wanna buy it and integrate, it's probably simpler, or I wanna just transform or work with a company to get an existing agent and improve it, maybe open source. I gotta make the decision, but as a CTO, now what I've just said is, I've got my agent for my company, either internal use or kind of, I wanna build an agent to sell it. I'm gonna build it from scratch, I'm gonna use this specific framework, I've decided, oh good, let's proceed. So what kind of agent and how autonomous? From the 5-layer, the set 5 autonomous levels we've just seen, what's more, maybe not exactly the point, but is it more kind of a code development, or is it more fully autonomous, and what does the human review? So kind of defining the task and the agent card, as we said at the start, and then identifying what are the capabilities and how autonomous do I need. One example could be, do I want it to be multi-agent and multi-domain, or should we go more single agent, single bounded task? So we decided, yes, I need to use an agent. Yes, that a specific agent card. Hello agent, that's who you are, that's your tools, that's how autonomous you are, that's how you work, that's what you interact with. Then how do I integrate it within my system? It's very important, because I need to look at my specific technological and human processes and see how I can plug that in. to the context layer, so data, information, knowledge, wisdom pyramid, but also what data access is required, is it properly scoped, what APIs and systems should I sandbox it. So really looking at how I can integrate it and make sure that it's used in production by the people that are the end users. Is it my employee that need to use that agent? Then I need to talk to them to understand what actually they need from the agent. Sounds banal, but it's very important because they may have specific processes we don't know about, but the agents will actually be useless if it doesn't take that into account. And then how do we measure it? So if we cannot measure the anomaly, we cannot detect it. So we need to make sure that we know what the audit trace, so what, why, who, what happened, the outcome, what does success look like? How can I measure success? If it's not monetary, is it hours saved? Is it documents saved? Is it improvement? Is it efficiency? And then finally, and most importantly, the governance. So when do I trigger anomaly review? What framework as a governance do I have? Is it Aura? Is it another framework? How is it built? So was the owner for that agent? What's the kill switch procedure? What's the risk gating? What's the review cadence? And what's the escalation behavior? We've got our 5 points here. So should we have an agent? Yeah. What kind of agent? That's the agent card. That's how it works. How do we integrate it? That's the tools that I access with. That's how it works with my data. That's how it's connected. How do we measure it? That's the improvement layer. That's how it's set up. And that's how it actually helps with the processes. Who controls it? How do I govern it? That's the person responsible for it. That's how it's governed. That's how we have the audit. That's how we control it. And that's how we have an improvement procedure in place. So that's it for the main section of the talk. I've been given 2 Q&A to answer, which we've actually seen through this entire conversation. So what are the key organizational and technical factors required to successfully build AI native enterprises? So in a sense, we've already seen that, but I will say from an organization, we've seen how AI native can be a complex term. So in a sense, you can say AI native can be a very big kind of, it can be a buzzword, it can be a very big word, it can mean a lot of things. If we make it simpler, it basically means that for process, we look at AI as a way to improve it and streamline it and make it simpler. So the first one is the openness, making sure that we're open to AI as a tool, open to AI as actually transforming and improving the system. It's a prerequisite, obviously. So if needs be training or showing the positive aspects or showing how AI can be helpful. Once we've passed that first very big but important hurdle, we look at then how we can implement it securely and safely, and also how we can make sure we have the ROI. So we looked here at a 5-step framework to do so, but it can be as simple as looking at a process, saying how long does it take, how do you do it now, looking step by step every aspect, and say, okay, this is how you could actually have an agent. Simplify that, and then initially asking, testing. We've built that agent with Claude Code. This is not how it's actually going to be, but it's a sample, use it and give feedback. And then you have that feedback loop, and then you actually go and spend all the money to build a full system that actually is then with all governance and ready to be in production. So I'd say openness to testing AI, point 1, key organizational factor. Point 2, obviously, the knowing how the processes work and knowing how to improve the process and making sure we tackle the right points, and also technically making sure we have the right infrastructure and architecture. We've seen plenty of examples on how to build agents here, but making sure we have the right steps in place and the right systems in place and the right governance in place. Question number 2. How can frameworks like Aura help balance innovation speed with risk management and governance in autonomous system? This is a very good question. And that's actually one of the reasons we came up with Aura in the first place. We realized that one of the biggest problems for governance is not to govern per se, but it's to govern at scale. I can know one agent action, I can check what it's doing. But when I have thousands of users, millions of users, and billions of agent actions, we've seen crazy usage of LLM tokens by some companies. We cannot have a human reviewing every single thing. And with Aura, we literally had this idea of saying, how can I optimize that? So certain things, I don't need to review it. If I've done this 1,000 times before, and I know it's safe, and it's the same exact action, the same blast radius, the same risk, I can just approve it. But this is where we need to balance innovation speed with risk management. Because certain times when you want to add capabilities and add things, you need to always have the start as lower kind of start, where you actually go, checks everything, check more things, have more system in place, and then as you go, as you take speed, as your engine is running and going, you can reduce the amount of checks and balances while still being governed and obviously legally compliant. So in autonomous AI system, I think if they're fully autonomous, makes it more complex, obviously. So start with lower levels of autonomy and then increase the autonomy as the capabilities goes. And very importantly, I think that's probably one of the biggest takeaway is look at through this 5-step framework or anything else, look at how it actually performs in production. Look in the production environment with the end user, with the end data, with the prompt you're actually having in the end system, how it's actually performing based on the right metrics. So once we got that system in place, that's where we can innovate, that's where we can have fun, that's where we can work, and that's where we can be governed and safely. Thank you very much, and thank you for listening to me. If you want, please do connect on LinkedIn. I'd be really happy to, and have a chat if you have any questions or things you would like to bring further, or if you need any help with agile governance, I'll be really happy to. Thank you very much. And again, this was a talk for AI in the new era, and it was about agent governance for CTOs and organizations. Thank you very much.